Everything we touch and see is made up of matter, but matter itself is not just a featureless substance. If we look closer, we find that ordinary objects are made of atoms, and these atoms are built from even smaller organized components. This layered structure is fundamental to physical reality. The main idea is that beneath the surface of what we experience every day, there is a hidden order, a substructure, that organizes matter at atomic and subatomic level. This organization is not random, it follows strict physical laws and models. Understanding this helps us appreciate that the world is much more structured and fascinating than it appears at first glance. The microscopic scale, energy doesn't flow smoothly like water. Instead, quantum theory tells us that energy comes in discrete packets or quantized states. This means that particles such as electrons, protons, and neutrons can only exist in certain allowed energy levels. In the nucleus, protons and neutrons are not free to move anywhere. They are bound together in what physicists call a potential well. This model shows that stable nuclear states require specific energy conditions to keep the particles confined. These concepts, quantized energy and the potential well, are essential for understanding why atoms and their components behave the way they do. Classic image of electrons as tiny planets orbiting a nucleus is outdated. In modern quantum theory, electrons are described by orbitals, mathematically defined regions where there's a probability of finding an electron. These orbitals are not fixed paths but rather clouds of likelihood, shaped by the wave function. The squared magnitude of the wave function gives us the probability density, which tells us where electrons are most likely to be found. This shift from the Bohr model's fixed orbits to quantum orbitals and probability distributions marked a major advance in our understanding of atomic structure. It's a vivid example of how scientific models evolve as evidence improves. Sum up, the structure of matter is governed by several core quantum concepts. Quantization means that physical quantities like energy only occur in certain allowed values. The potential well is a model for understanding how particles are confined in stable states. Orbitals are the regions where electrons are most likely to be found, and probability density comes from the wave function's squared magnitude. Finally, as our understanding grows, older models are replaced by more accurate ones, a process known as model revision. Together, these ideas reveal the hidden order and complexity within everything we touch.